happy to welcome you, to inform you a bit about this innovation radar, and I'm glad that Tamim is here. I have to first apologize for my colleague Anne Bajar, who co-organized this workshop with Tamim, but unfortunately she has the flu and had high fever this morning, so she had to cancel last-minute participation. But yeah, this workshop was developed with her and Tamim. So what we want to highlight is the importance of innovation in our project. We know that we have excellent teams in Europe producing excellent research results, excellent papers. We have great professors. But one of the problems we have in Europe is that they produce wonderful results and they are somehow not always acknowledged and not reused. So the Innovation Radar program is a program which is there to identify in all our projects the potential for innovation. Innovation in various types of innovation can also be research innovation. It's not only in terms of companies. So let's see a bit more what the Innovation Radar Prize is. So it is part of our evaluation. So, you know, we monitor our projects, and one external expert is dedicated to fill in this requirement on Innovation Radar. The goal of this expert is to identify in every single project what are the innovation potential. Innovation, it could be a module, it could be a source for a new product, for a new service. So they scrutinize the whole project to see what are the potential, and the goal is actually to highlight those and then to help the project really exploiting, making the best out of these results, in providing them with visibility and then with some help also to exploit those results. I had in the past an example where in one of our projects, so this kind of innovation had been identified, and one of the results of that they were invited then for free to go to another fair and explain it. So these are the kind of activity that could result from this Innovation Radar. So we take it very seriously because there is an added value. We want to demonstrate also what is the impact of our project, of our funding. So this is important to highlight that. So we have launched this Innovation Radar program really to identify really the top innovation in our EU-funded project. So in this process last year, we have identified 48 best EU future innovation. There were much more, but they were classified. The 48 best ones have been selected to a competition to really be selected and take really the best one. So that was part of the competition. There were 20 finalists, and they had to to compete for the final prize. So these, as I said, there is a number of categories. So we want to identify either the potential result which can have an impact on the society and on the citizens. That's one category. The other category is excellent science. So we know that we have excellent science, but it's important to acknowledge and give them visibility as well. Not only to the scientific community, because that they have when they go to conference and so on, but we want to globally make them visible as well. So cutting-edge science underpinning tomorrow's technology advance. So this is the second part. So the third one is industrial and enabling technology. So identify the next generation of technologies or components to support the industry. The best young SMEs, so that's also good to support them. So again, another category, and the best early stage innovation. So again, it's the detecting in some project some promising innovation in these projects. So it does not necessarily have to be the whole project; it can be components. So out of all those projects, there were actually a number of robotics projects selected for the Innovation Radar, and there were 3 of them. And they were resulting from the SPARC strategy. And we had like bots to Rex and Robotics, AeroArm and Catec, and Romance and EasyBot. So these were the project and the corresponding company or exploiting the one producing the result which have been identified. So we will have the presentation of those projects, and I'm not going to say who was the winner, you will discover. Okay, so what is the goal of this workshop? It's really to present those successful projects and those innovations, and discuss as well with them how it works, how to really promote this innovation, make it visible, and what is the result of this innovation rather? Is there something to benefit from, to improve? And so it's to share experience and learn from these good practices and have recommendations for the future. So now I give the floor to Tamim, who will complement this introduction.
Okay, thank you, Cecile. Yeah, hello from my side too. I'm also very happy to be here actually and to talk about innovations in EU-funded projects. And I have some remarks or statements actually which I would like to share with you, and maybe they could be important for our discussion at the end of or after the presentations of the 3 finalists and 3 selected talks from researchers who are doing or transferring their research results to industry. So the first thing actually I would like to emphasize is the fact that there's no innovation without basic research. And we are so lucky in Europe these days that we are talking about technology. We have a lot to transfer and a lot of innovations going on, as we saw. I'm so happy that robotics actually was the winner of the Innovations Radar Prize last year. This is a big success for robotics as a whole. And we are now in this lucky position because actually the European Commission invested a lot of money in research in FP6, 7 in basic research. And now we are actually collecting these results and transferring that to industry. And I see the danger that if we only continue by doing this line of research, that in few years we will not have anything to transfer and anything to innovate. My next statement is actually regarding the initiative of European industries. I'm really, I don't know how to explain that or how to express that, but big European industries actually prefer to establish their research labs on different topics outside Europe. So what's the point? What's the problem in Europe? Is there a strategy in Europe actually which also allow these people, these big industries, to do these great innovations in the European Valley and not in Silicon Valley? And I think that innovation is the goal of everybody of us. Nobody is doing research just because it's only fun, yeah? I mean, research is fun, and everybody would like to contribute with her research or his research to the society. But I don't think that every researcher or every scientist is a good innovator. At least I cannot do it myself. I don't know actually how to do it, and I haven't seen it as my task so far, yeah? And the question is how to deal with that. And I would like to discuss with you these issues after the presentations. Second, related to a European strategy actually regarding innovation, but in particular regarding protection of European research and innovation results. What are we doing here actually? How can we, for example, use results which has been developed through European funding here, protect them in these times of changing world? Actually, we are now living in a world which is actually managed by Twitter, yeah, by a person who is actually managing his country, but all the world maybe by Twitter messages. So how can we react? How can Europe actually react in these times? How can we react in sense of providing real opportunities for our researchers who are actually developing innovations in the US, in China, and other countries to stay in Europe and to do that in Europe? How can we prevent actually the brain drain from Europe so that we can have more innovation in Europe than what we have now, and where we can strengthen actually the potential of Europe in terms of research, in terms of technology transfer and technologies which improve our planet or the quality of life of humans as a whole. These are just few statements I would like to discuss maybe at the end after the presentations. I will not waste more time on that now, but would like to continue or to start with the first presentation with one of the finalists. This is Tim Detart, who will give the first presentation for bots to rec and robotics. Tim, yeah, please.
Thank you, Tamin. Okay, so yeah, welcome. Thank you for the introduction. My name is Tim Detert. I'm the scientific project manager of the Bots Direct project, and I would like to use the time to show you a little bit about our project and our approach to innovation in the first 2 years of the project. So here on behalf of our 7 partners who started in February 2016, so pretty much 2 years ago, to establish a robotic system that is used for asbestos removal, so to clear and refurbish renovation sites from hazardous asbestos, which is a large part of the impact we want to generate, and on the same is having quite a market potential due to the situation in Europe, and I'll go into the details of that in a minute. So first, let's have a short look to what asbestos is. Most of you might have heard of it. It's a naturally occurring mineral, which you can just dig from the soil, and it's forming thin fibrous crystals. And it has really good mechanical properties. It was used widely in construction materials like plaster, glue for tiles, in paint. The problem we have nowadays is that we now know it's hazardous to humans. So it's causing severe lung disease, it's causing cancer, and we need to get rid of this burden. And I'm saying it's a burden because if you have a look to the history, Europe or all over Europe, a lot of asbestos was imported and used in construction industry and other domains in the recent decades. So from that you can say there is millions of flats and buildings that still need refurbishment. We did some calculations based on the not so good data, and you can easily say that it's more than 50 million apartments and flats that still need refurbishment in Europe. So that's what makes the big impact for this project, and on the same gives you a good opportunity to use robotics for this. So why is this refurbishment critical and we need new solutions? Because it's a very dangerous work and safety regulations are very strict. So what you see here is workers in the according protection suits, and this is causing high labor costs because they are only allowed to work for 2 hours, then they have to take a break, and this makes the whole renovation very tiresome and often too expensive to perform it. So that's why people or companies or builders, owners of flats often do not refurbish but hide the asbestos and keep the problem for the next generation. So on the same, if you have a look to such a rehabilitation site, what you see here is a typical rehabilitation site that gets covered on all the areas that are not contaminated, and on the same here the ceiling to be processed is accessible freely, and we have a relatively structured environment in comparison to a standard construction site, and a relatively good conditions for automation, so the use of robot is comparatively easy, and the task we want to do, grinding a wall, grinding a ceiling, removing the plaster, is comparatively of low complexity, so that's why it's a good starting point to bring robots to the construction sector in this case. So the overall approach is that we're starting with an empty room, we're generating a 3D map just as a representation of the site, and then we're going to use robotic systems that enter the site and that semi-autonomously do the removal of the material from the walls, from the ceiling, always remote control, or always supervised and partly remote controlled by an operator. So the idea really is to keep the operator in the loop and have a look at the overall process. So the operator will still be the one to identify the asbestos before we start the removal job. He will still be the one to supervise the result in the end, and he will be the one to make decisions of what's contaminated and not. So we're really trying to focus the autonomy to the tasks that is a big problem and dangerous at the moment, and that's really the mechanical removal of asbestos material, and for us preferably from flat surfaces because it's relatively easy and the largest amount of contamination we have. So to sum this up, the motivation really is to get a step change from this manual removal you see here on the left, which is tiresome, which is dangerous and dirty, to a robotized solution we can use in a convenient way and to demonstrate it in an operational environment. Okay, so let's have a look at the prototype, which actually is the reason why I'm standing here. We developed the very first prototype very quickly within 1 year. We had to respect very limited requirements, so the platform is rather small. We cannot exceed a weight of 300 kilos because we need to move around in flats, and that made us develop a first prototype very quickly to have a testing platform at an early stage, and that's what you see here. Not the final product robot clearly, but it gave us the opportunity to do some testing with the customized robotic arm we are using. With the aspiration system, we have a vertical slider to enlarge the workspace according to the needs, and we're guiding a passive compliant tool for the very start to just get an idea of the removal process and see how the overall system is behaving. And what you see here is the heavy payload platform. So with this small footprint, it is still able to carry 200 kilos plus the weight on its own, and that's what Robotics brought to the market after 1 year in the project, and that's what gave us a nomination for the innovation prize in this case. Furthermore, of course, the big innovation of the project will be to bring such a system to a new domain in the end if we get all the processes running. Okay, then I would like to show you some insights to the central process control system. Really, like I said, the idea is to have autonomy of the robot where it's useful, so the actual grinding process on the wall, and this will be accompanied by a visualization and camera feedback, so you always have a representation of the robot in the site on this 3D map, which is, well, for the moment sketched here. And you can choose the parameters of the process, you can receive error messages, so we really keep the operator in the loop, but on the same sum of the planning, like you can see here, where does the robot operate, what trajectories is it choosing, what are the process parameters to perform, is done autonomously by the system, while all the time having the feedback, which we in this case implemented in a ROS framework, because it gives you a lot of opportunities to work with existing research results in the end. And furthermore, you, for example, here have a feedback of the process itself, so you can always check where there was removal done, whether it was successful, where to check for the results, and where to do manual afterwork as well. So this is not going to be a process that's 100% automized in the end, but we try to reduce the manual work as far as possible. Okay, I've been talking about the 3D map we want to generate to get an insight for the operator to what the reality looks like and where the robot is located, and on the same for the navigation of the robot. So we can use a high quality scan which is available on the same as a, I would say, small research activity next to it. We're checking if we can reach that with a really simple and cheap solution as well, based on 3D cameras and really a small and simple turtle bot. It is, however, not changing the course of the idea. If we have a 3D map which we can generate in different ways, we can operate and control the whole process. And here you see our first testing results from, well, early summer of last year actually. We have a testing site in France which allows us to do all the tests of this grinding in a not dangerous environment, so we're not having asbestos there, but we're having the representative materials. And what you see here really is the first movements of the robot, checking the behavior, seeing how we can implement a position control, and doing first tests on the process. So what are the parameters we need to really grind the surface? What are the forces and parameters we need to grind deep enough? And a lot of the work now will be to figure out how can we identify if we've grinded all the material, how can we control the process in such a way that we're removing the material as efficient as possible, because in the end we will get this only to an innovation if we manage to be more efficient than the human in the overall process. That means maybe with working 2 shifts without having to take a break for security reasons and so on. But what you can see from the beginning, there still is a lot of work, because it is not an easy process to operate with a robotic arm, especially as it is in our case with the robotic arm with quite a long reach, relatively low stiffness due to the low weight. So we're facing some challenges there, but I hope to be able to tell you a bit more final results next year. And this is finally one last approach I want to show you regarding the control. So what you see here is a test we are running at one of the participating universities. It's a simple 6 degree of freedom robotic arm. We're not using the 7th axis, we're not using the internal force sensors. It's just the robot that was available. And this is one of the basic research we're still doing in this innovation, to develop a hybrid control system that allows us to maneuver the robot to do the process with a given force on the surface, and on the same allow the robot to follow the surface we are treating just by the force signal. So this is a lot of the research that has been happening in the last few months, and we're going to transfer this to our first prototype and the second prototype under development to finally get to a system that is able to cope with the overall removal process in an at least semi-autonomous way. Okay, so that was my presentation, giving you some insight, and I'm looking forward to the discussion later. Thank you.
I hope. Thank you very much for your introduction. Thank you also, Cecilia and Anne, for inviting me. This is my presentation about AeroArms results. I'm Kateka, I'm the coordinator of AeroArms. So what is AeroArms? It's innovation, research and innovation projects dealing with aerial manipulation and also the application to inspection and maintenance. So the first objective is to continue developing the aerial manipulation methods and technology that we started in ARCAS, the previous project, and then we wanted to also apply, so we developed the very first dual arm aerial robots, also the fully actuated with tilted rotors, and also new control perception, planning, and calibration method. But we also developed the validation applications for the validation in inspection and maintenance. We have 3, and I'm going to talk about the first one, the contact inspection. So I will put the first video. So this is the justification working at faith, because the results can be applied not only in the oil and gas sector, which is what I'm going to present later, but in many work at faith. In the lab, and later we tested in the outdoor. So in the outdoor, you can see here how we tested. First with the string. The strings are mainly for safety, but this is not affecting the control system. And you can use in every direction in the way that you can also measure the depth of the wall of the pipes, which is very important to measure for the corrosion. And then from this, we went to the different experiment that you will see later without this string. So now, we are developing this next generation of inspection for many of oil and gas industry. Why? I will provide some dates. So these are dates related to Europe. So there is 5,000 labor accidents, 300 millions. Just one single refinery has 40,000 kilometers of pipes, and then 50,000 measurements every year. So that means that every year this is needed. Also, we think that with this system we are targeting both the owners and users, refinery owners, and the inspection service providers. So in the first, we will produce savings, and also we will perform faster, 10 times faster. And in the second, I think that the business will be more competitive and there will be no accidents due to the height. So I think that this is the industrial first and unique contact inspection drone. These are two statements from the end users. So CEPSA is the main company, petrol company in Spain, and the inspection service provider is TÜV-Nord, which is a member of TÜV-Nord, which is a partner of the project. So that means that they think that this is very relevant. And in fact, the market is 2 billion in the world. And only in Europe, we have 101 refineries, and there is in Europe more than 40 service providers. So we decided to address the market through the service providers. Then we decided this plan. We will create a product from our technology, and when we will experience, we have some experience already, and we provide a solution for all these big companies. We have a patent, and then we will produce in AeroArms a technical pilot, and then we will start activities in such a way that in 2019 we will have a commercial pilot that could go to the market in 2019 and 20. Before AeroArms, we had ARCAS. In ARCAS, we develop basic technologies. In AeroArms, we are applying this technology. Both are research and innovation projects. Then we have right now flying more than 500 hours every year, and I think that we are in close contact with the company. So I think that only to convert this product in let's say, this development in a real product, it is only needed something about 500,000 euros to obtain a commercial pilot. So this is the Euronews visited us. By the way, it was the only day that was raining in Seville, but anyway.
This drone is making a buzz across Europe. With this technology, risky industrial inspections can become safer and more cost-effective.
Now there is not string.
It's the first of its kind because of its sensitive telescopic arm. Designed by Seville's Center for Advanced Aerospace Technologies, the semi-autonomous drone can carry instruments and push them against structures to check their integrity.
With these ultrasonic instruments, we can measure the thickness of the pipe. As you can see, we can also detect defects or corrosion. These sensors need to remain in contact with the pipe to give us this kind of information.
Developed within an EU research project, this technology is aimed at the commercial market. So far, countless pipelines at industrial facilities have to be inspected manually, in particular in the oil and gas sector. It's a slow, expensive and dangerous work.
This drone will allow us to carry out these tasks at a lower cost, saving a typical refinery 700,000 euros a year. The inspections will be conducted 10 times faster and without height-related work accidents.
This project was selected among the 20 finalists of this year's Innovation Radar Prize, a European Commission initiative to identify EU-funded innovations with high market potential. At the final in Budapest, all 20 teams pitched their proposals to the expert panel.
We are looking to partner with potential biotech or hardware specialists.
We see a great potential for financial success.
This is a market opportunity of 2.5 billion euros.
We are in close contact with potential clients and end users. We aim to create business from our unique technology.
So it's very important that taxpayers know that their money is actually very productive. that it leads to innovation, it leads to products. It's one thing to have a brilliant idea in the lab, but as we all know, it's another thing to bring it forward so that it can get into the market. And it's this combination that we're looking for when we award the prize. Ladies and gentlemen, it is my honor to announce the overall winner. It's Catec Industrial Drones.
They were convincing. So we didn't focus about the fact that it was a drone. We were focusing about the fact that they were answering a market need. And they could demonstrate that they could save money and they could save lives and make it faster. So I think that was the reason why we end up by choosing them.
Okay, I think that this is...
The prize puts the technology in the spotlight. When the research project is finished, the developers want private investors to help turn their prototype into a commercial project.
I think that I will go for the conclusion. So my conclusions are, right now we have the development of new aerial manipulation technologies in the research and innovation project AeroArms. We have validated in indoor testbed, but also you have seen the outdoor validation in a relevant environment. We want to integrate with other systems, and we also to have an industrial demonstration in Spain and also in Germany, hopefully this year. So I think that this will be in industrial demonstration this year. Thank you very much for your attention.
And congratulations for your prize, anybody.
Thank you very much for inviting me, and we were very happy to be nominated for this. So Romans is about using, can we take what we learned in FP7 about advanced robotic grasping and manipulation, and can we apply it to handling, sorting, processing nuclear waste? Segregation means separating the high-level waste from the low-level waste. So the UK alone has nearly 5 million tons of legacy nuclear waste. It will cost 200 billion to clean that up over the next 100 years. It's the biggest environmental remediation problem in the whole of Europe. Worldwide decommissioning costs of order 1 trillion. A very large amount of that must be done by robots, right? Must be done by robots. However, nuclear industry is very conservative. It is almost completely unroboticized industry. There is almost no robots ever been used for anything, anywhere in nuclear. Oh, the video is not there? Here we go. So this is a test bed set up by Sellafield and National Nuclear Lab in the UK to see whether large KUKA robot arms could be used to examine old nuclear waste and process it. These videos are massively speeded up. So this is very, very realistic, but fake nuclear waste. It's not really radioactive, and they're testing whether humans can control with joysticks to see whether this can be done. It's still just joystick control with TV cameras, and is very, very slow because the consequence of crashing the robot or dropping the object is very severe. So in Romans, we want to see what can we do, take from our laboratories to help improve this, make it quicker, faster, cheaper, okay? At Birmingham, we were looking at autonomous grasping and manipulation. That came out from FP7 GERT, and also Darmstadt, Gary Neumann, Jan Peters, good on autonomous grasping. CEA, the French nuclear agency, they have wonderful robot lab, and they're experts in this haptic feedback. Can we make a smarter joystick, haptic telepresence? And in the middle, we have here a human teleoperating this gripper arm, and the AI is assisting him, orienting the gripper for him, right? And the AI gives haptic cues, you know, if we don't want you to go to a difficult configuration, or, you know, so the AI and the human are sharing the control, okay? So those were the three strands, really. I just wanted to focus on innovation. So here is what was one of the most advanced machine learning-based autonomous grasping algorithms from our lab, and transferred here to the National Nuclear Lab nuclear industry site. That's the first time in history that anyone has ever allowed a robot arm to be controlled autonomously, AI path planner, grasp planner, vision guided, under full nuclear safety regulation, full national security regulation on a UK nuclear industry site. But this is fake nuclear waste, it's not really radioactive, okay? But still it was very difficult to get that onto a site. Here, this is the first time in history that anyone has ever done an autonomous robot arm in a real radioactive environment, okay? So this is vision-guided, AI-controlled arm, laser cutting, contaminated radioactive metal. That laser is so powerful that if our path planner goes wrong and points the laser at the wall, it will burn a hole through the concrete wall of its own cell and let the radioactive dust come out, okay? So in terms of getting AI out of the lab and into the real world, this is about as real as it gets, right? This is a significant achievement. Just to summarize the various innovation that came out of this project. So CEA did a lot of the work for their new robot arm came from Romans, and that turned into a spin-out company, Isibot, to market this arm. And this is what was the finalist for the Radar Prize. And it is an arm that is compliant, a bit like a DLR KUKA lightweight arm, but it uses mechanical engineering principles to be compliant. So you don't need a lot of electronics, so you can use it in a high radioactive environment, right? They also made a novel dexterous hand that's being commercialized, novel dexterous hand exoskeleton being marketed by their spin-out Haption. This laser cutting work came from University of Birmingham researchers through our spin-out company ARM Robotics, and we are now licensing that software to the UK nuclear industry for the laser cutting. I also spent the past 3 years with my postdoc embedded in the UK subsidiary of KUKA, and we've been transferring this autonomous grasping work into KUKA, and they sell the robots to the Jaguar Land Rover car factory, this kind of thing. We're looking at transferring that to bin picking of car parts, you know, for the automotive factories. And as a result of Romans, and I honestly, I came within 5 seconds of deleting the email because I thought it was spam. I got an email from this venture capital investment bankers saying, we've seen this project Romans, you know, and this looks interesting, could we give you a call? And I really thought it was, you know, but they have now ring-fenced 20 million euros venture capital towards, you know, seeing how we could commercialize, turn these things into spin-outs and market this stuff. And they have committed that 20 million to new robotics projects. And the main one of those, I can announce, we've just created the new National Centre for Nuclear Robotics in the UK. It's initially a consortium of 8 universities, but we have industrial support and nuclear industry support spanning 3 continents, USA, Europe, and Japan and Korea. And this will be running, and we hope to permanently establish this as a national institution. And we'll be talking more about this at the workshop tomorrow, which is dedicated to nuclear robotics tomorrow afternoon. Thank you. Yeah, I didn't go too much in because I did 7.5 minutes. But we did. There was a huge range of things that we did, you know, all sorts of vision manipulation, teleoperation, haptics, shared control. There's a very wide diversity, okay? So at the moment, if we do not develop advanced robotics beyond the current state of the art, just for the alpha contaminated, so not the high radiation gamma, just for the alpha stuff left over from the Cold War, 1 million entries will be needed of humans wearing plastic suits with air hose. Each one of those plastic suits becomes secondary nuclear waste. So for every 1 container of the real stuff they're chopping up, they're making 11 containers of the secondary waste. Each container costs you, the taxpayer, costs you millions to be stored and monitored, right? If we put 1 robot in there and it's teleoperated from outside, and at the end we chop up the robot, throw it in 1 extra box, it's no problem, right? So, yeah.
Okay.
Thank you. I was invited shortly to give 5 minutes overview of challenges, good practices, difficulties and recommendations. I mean, there's much more to say, so it's my research point of view that is presented here. So one of the difficulties is always the expectation. Because nowadays AI is so much in everybody's mouth, and robotics too, but there's a very distinct factor in between, and that's the speed on how things develop. You know, computing power doubles every 2 years. Motor power doubles about every 12 years, particularly on robots. So payload and so on, you know. It took 40 years to build a compliant robot, you know, coming from the first one. Don't forget that. I had a highlighting workshop yesterday when the Odensee people invited an investor here and said, yes, of course, there are many investors that are not at all interested in hardware because it just takes too long. They expect something like a prototype in 3 months. Yeah, you can do that for software. There's nothing for hardware. So it's a totally different type of people who work in hardware and in software. So please never ever mix AI and robots. Always keep them together or do them completely separately. But it's software and hardware and it's something different. The next thing we always have, the first question I get in every talk I do in Austria with a larger audience is, you know, we are basically from the anxiety of their machines, their robots, they take our jobs. That's the first thing. So that's another thing we have to fight, and that's a typical European thing. You don't find that in Asia. I mean, ever go to Japan, please do that. Robots are everywhere and it's fun. Yeah, other machines are everywhere and it's fun. So, you know, I think that. And another thing, I think sometimes the Commission goes a bit too far. Not Cecile, you. I mean, other parts of the Commission. For me, robot is a machine. Just don't over-regulate. I mean, you know, it's so easy. It's clear, but then, you know, and we have fantastic standards that make sure that humans keep safe. Another thing I think that is unknown, and particularly, I mean, I have seen now so many talks in the Maestro up there on cobots out there, and there are like 50 trial installations. But I've never found anyone who is really telling me what the collaboration is really about and where is the benefit. It's just, it's a bit of a hype. Even today, they themselves said it's kind of a hype. And it's even more so for the robots at home. I mean, there are full conferences where there's Wizard of Oz studies because they don't have the robot, but they believe people would want something, like a companion, friend, whatever. Our findings is totally different. I will give you an example. And in principle, we still don't know what people really want and really do if they have a robot at home all the time. Okay, coming to some best practices. I picked out 2 examples because for me they highlight how it worked for me to get things from research all the way into a company. So we had this wonderful GRASS project, some national project. We basically can either show any robot to the system, any object to the system, or just give it a CAD model. It can learn the variations, and you know, it can detect the object, track it, grasp it and so on, that's okay. And we published that, and via the publications, the companies came and first took people, so the heads, and second gave us further contracts for research. And the same thing happened with a really old FP7 project, Robots at Home, and the successor Hobbit, which was the robot running before you saw, and that's the new version. I mean, you know, the outcome was just enormous. We had the 2D navigation at home, which really showed that would work. We had to pick up everything from the floor. And what was, you know, you cannot put that in a real paper. And like one single fact, we had robots in homes of older people set free. They could do with the robot whatever they wanted. It was not like a script that they had to do something every day for more than a year in 3 different countries in Europe in 18 apartments. This is an experience that we really started to learn, you know, what people might do at home. And again, because we published, a company approached us, and the new version of Aeolus is a 3-continent company. They have sites everywhere, including one in Vienna. This like the successor was shown at CES, which is the Consumer Electric show in Las Vegas in January. So also problem solved? No, not really. So I think there's still this problem of this difficulty of robot complexity. There's so many things you would want to put on a robot that's going on at the same time. So if you come to the platform, I'm still looking for the affordable mobile manipulator or cobot. And if you remember Peer 2, it was a big push. Nowadays I see, you know, everybody's like tinkering, and then the hardware is not really working, and we have a project where again the hardware is not really working. Maybe a tender and separate it. Don't make a tender with partners that use it. Make a tender for the platform and the second one for, now we have that, who is going to use it and what's the best use, and then give it out large. I think then we have a profit because everybody will contribute to that one system, and then we can again spread out and, you know, diversify. You know, we get a bigger platform, a smaller platform, and that might be different companies who do the innovation and really the uptake. But I think that's the way to take. Same thing, ROS speeded up things, but still there's system robustness. You know, you have so many components. One fails just only, or one fails only 1% of the time. But if you have 100 of them, you have a system that's never ever going to work because there are just too many components that fail a bit. So we need to do something. I think Robmoses is one of the things in the right direction, but it's not by far not enough. It's a tiny step. And my final research point is, please, we need to understand. I'm nasty here and say I don't need deep approximations. I really want to understand. And the industry goal, in my opinion, is we had a large study in Rocky U2 where more or less industry people said, I would like to teach the robot like an apprentice, but that also means that then the robot executes the task and can even explain what it's doing so that I can correct the robot and tell him, no, it's not done like this, it needs to be done a bit differently. And this is the way that, you know, there is a responsibility there. So we engineers know what the system is doing. We can justify what it's doing. I'm not happy with the transparency issue because, you know, you can open any deep net and say, you know, there's all the data, but I have nothing to do with that. I mean, what do I do with that? I want the justification what the system is doing, and then at the end I will trust the machine. So keep robots and AI together. And sorry, that's a wish from me, but Tamim took the point away already in the beginning. So, you know, this is a famous teaching of probabilistic robotic. I guess at least many of you will know that. So the robot goes along and finds something. The first thing we find is due to research we found something. And, you know, there's progress. That's the red thing, and we just don't know exactly where to use it. But then we find the next thing, and that's the innovator. It's a different person, exactly as Tamim says. We find the innovator, and these two together give this peak. And now to Tamim's point, you know, what are we doing next? So I think, you know, largely speaking, FP7 was fantastic for research. Horizon 2020 is doing great on innovation. I would like to see a bit more research again. That's my view. Thank you.
Yeah, thanks for a lot for the invitation to speak about the topic here. So I've been, before founding a company, 15 years in research at the German Aerospace Center, and always dealing with perception and all the challenges that have been there. And at some point it was time for me to go and found a startup. The other option would have been to license into industry, but I will talk a little bit about it, what the differences are and where you want to go. So for me, the main statement is, like, if you're in robotics, we have also vision. There's a vision community that does vision, but it's not robot vision. And you have these two communities. One are mostly interested in the algorithms and like complexity and that stuff. And then you have the kind of people that have to deal with real life problems, solve it, because actually if you're doing robotics, there's problems to be solved by that. And this is one major thing that you have to consider also in the innovation, that the perception and the action, the manipulation must be somehow coupled. So it's not like one topic that you have to consider, but you have to understand the chain and to see where you are in this chain and what comes before and what comes after, because in most cases you probably cannot do it all by yourself, especially when you're later on going for products. You need to keep that in mind. The main motivation that we had is like that flexible production requires vision. Because if you now have a production system that is totally automated, there's not flexibility. This is done by mechanics. And if you want to do this by software, there's a good reason to doing it with perception. In robotics, you have real time. In vision, you usually don't. So that is a big difference. So if someone proposes you a nice algorithm that has 99% something accuracy, and you ask for the runtime, then usually the discussion ends. So that is really something that need to be considered. Also from the basic research, it's important that you also see that you tune your algorithm to the application. So if you need real time, not everything that's nice you can do. And in addition, that comes from the business side. That's not so relevant on the side of research, that users really need intuitive and integratable robotic solutions. So in the end, there's someone who wants to use your software, who wants to use your application. And this is not the guy that has a PhD or a professor in the certain domain, but it's a guy that's just working there, wants to get it done. And yeah, if you have a huge barrier for that guy, then it's probably not going to use it. This is what we are facing right now when we are going to perception and talking to customers. They usually say, I've seen many things fail already, so why should we work with you? And that is really something mostly on the setup and all that stuff that is relevant, that you consider at some point in the process that there's a customer that you need to convince. It's not only everything is customer based, but at least in some points you should consider that these people are there. And ready to use and easy to use functionality, also important, because time really matters, and changing a production, changing things, that is important. So keep in mind that this in the end will really make the difference on the market. I show you some results. Some of you have seen that before. What I talk about innovation here is interesting because classical industry likes to have an image and a depth image and a range. What we are also providing right now is like the error image and the confidence image. That is something that is newly pushed by artificial intelligence now, but when we started 3 years ago and I told someone about a confidence image, they were like, oh, what is confidence? What does it have to mean? So from research point of view, it's clear that you need it. Talking to someone that actually needs to implement it, that is a value in between 0 and 1. So what I'm supposed to do with it. And this is also something where you really have to check. You come from research, you go to a product, and in between there's a lot of things that are maybe nice, but you have to adopt it accordingly. I give you an example about intuitive configuration and calibration. Of course, most of you or all of us know expert GUIs. That's what usually comes with a product, but sometimes it's not an expert. And especially in vision, you have a lot of parameters you may want to change, but the customer doesn't, right? He wants to set it up, and if you give it the customer gain and exposure, then that's already 2 parameters he has to work with. And what we did is basically we have an expert GUI, which is based on REST API, and this is basically just represented on a web interface. But not all functionality is accessible via the web interface. So the programmer has the same interface as the non-expert, just we are selecting it by the GUI, who's getting what. And this is what makes all of the guys that want to do fancy stuff, they can access it, and the guys that just want to get it running have the same interface. Gives it robustness, right? Because it's the same interface on both sides. Some videos to that. That is a nice showcase. You can move sensors around. So this is also some functionality that we have in industry. People don't really ask for it right now because they don't have this case where a robot is freely moving in space. But in terms of flexibility, you will need it later on because you don't want to move the robot always in the plane area. That's the functionality we have. We can use it, but it's sometimes also hard to show. Same with navigation, mostly laser-based. This is why I like the, the introduction that Markus just did. So SLAM. SLAM is a research area that is kind of huge. It's giving you global maps. But in most cases, people don't have these global maps and probably also don't need it because manipulation is kind of done relatively. So the approach is nice, but it's mostly done on laser-based. But why are you not using cameras for that when you get so much additional value from it? And this is why we also went in that direction a little bit, to have the same camera doing two things. That's also important for innovation, that you can use your hardware with software for more than one operation in order to get that done. Showing you a little video how this works. That is basically in our basement. We were driving a turtlebot around to generate the data. And if you come a little later on, you see the point cloud, you here see depth, accuracy, and confidence. Confidence not so relevant for the customer, but later on we are using the confidence to improve the map. So what the customer is interested in is a nice map. So whatever the value comes from, and probably it doesn't understand it at all, but in the end you can optimize. So what we did right here is you just use the Octomap and included our confidence value into that. And this is also something we give back and make it open source so more people can use it. So that is also a direction where you say, okay, it's probably not a value that you make a product of, but you can give it back as an open source functionality. We did a lot on object recognition. That's still a challenging task because it faces a lot of problems with light and so on. And of course, you have to also adapt to the case that we are now working with a lot of customers that have their objects already scanned and so on. So also for perception, it's important to have such thing as an object database. Here we are facing all these problems in between the object database, which is accessible, it's a cloud solution, it's an edge solution, but still you need to have also that in the pipeline, because if you have an object recognition algorithm and you put it in the algorithm itself, the database, then you can never decouple it. If you come to a customer, you want to do object detection, he maybe has already his object database. So from the research perspective, you always couple it all together. From the product perspective, you have to put it in parts that you can maintain in order to reduce complexity. This is a very important insight from our side that we said, oh, nice. This is nice to have the full pipeline, but how do you make it so modular that you have a complexity in your product that you could later on really bring to market and maintain? And this was 1 year at least of effort to figure out how this can be done so that you have the functionality in the end, you don't double the data, and you still have a product in the end that the customer is also interested in buying. Just to show how this all together may look like, that may not be the thing that the customer gets in the end, but what is included is you have to the left, you have your world model and your objects from the object database. In the middle, the real scene. To the right, the confidence and depth image and the camera image. And we have a grayscale camera here right now. So whenever you see some objects turning colorful to the left, then this is basically something that we derive from the database. We replace the real world by the database. We get this database from the customer or from a modeling tool. But in the end, they may be interested in parts of that solution. We have to show the solution so that they understand that everything of this is possible. But still, in many cases, you don't really have to do it in the end. So the main thing for me from bringing innovation into a product is keeping complexity down, because a product needs to be maintained over a long period of time. Software products like 3 years, hardware products 10 years. If you don't select the right interface, you can kill your company by that, because you're maintaining the interface instead of the functionality. So it is really something that comes out of your research. You need to understand what is the core, what you are doing, and keep the product as less complex as possible, and still maintaining the functionality. So that's my main insight. So if you have questions, happy to answer.
So thank you for the introduction. So I was invited to say something about our experience about research and innovation in our project that deals with autonomous robot assembly. So many new technologies that gets developed in different projects, of course, never get implemented in industrial applications, since simply if you leave everything to, if you wait that industry will figure out that this is potentially useful for you, then you might be waiting for a very long time. So basically, the new research results rarely provide end-to-end solutions, and you need to basically speak to the end users to actually convince them to first identify how you can actually use your new technologies, and then finally develop industrially relevant solutions which companies are actually interested in. So in the Reconcile project, this original research was programming by demonstration that was done in many different European projects that we participated in, like, for example, the experience projects that was coordinated by Tamim and supervised by Ambajar, who isn't here today. So basically, we were not quite happy, how quickly these research results are picked up by companies. So basically, we looked at, we tried to identify an area where this could be really useful and have some impact, and we decided after speaking with some companies that assembly for few-of-a-kind production would be a good area. So basically, this is not yet automated in industry simply because it takes too much time to program such tasks, and programming by demonstration can actually offer a solution. And of course, it is always nice if you also then find a good funding program for such project. And for us, this was the I4MS, which stands for ICT Innovation for Manufacturing SMEs. And in this program, you can actually develop new solutions together with SMEs. So before I go to further explain Reconcile, I would also like to mention that there are other ways of transferring your results to industry. These are direct technology transfer projects. So as Marcus said before, it does happen sometimes that somebody reads your paper or actually sees your talk at the conference, or maybe he just heard from somebody, and then the company comes to you and actually asks you to implement this in the robots. So we have one project like this, but there is also a drawback with such project, which is that you're normally not allowed to talk to you about them. So this slide is not a mistake, but basically you normally sign an NDA and then you're not talking about it anymore. But it's very nice, of course, for researchers, because such projects actually allows you to deal less with the actual application-specific technologies, and you just tell to industry how to implement what they're interested in. So in a way, these are very comfortable projects. But now back to Reconcile. So basically, to make programming by demonstration useful for automated assembly, we had to innovate in a sense of developing many hardware solutions, which allows us to make workspace that is actually designed for assembly, designed for programming by demonstration. So basically, you cannot just rely on your original technology to solve everything. So the different innovations that we introduced, for example, like buttons for kinesthetic teachings that are here on the top of the robot. So if you saw Sami Haddadin's Frankas, he perfected this technology with a complex button interface that provides you much better control interface than classic teach pendants. And so furthermore, we introduced passive reconfigurable fixtures. We made big use of gripper and fixture design. And so this all would not be possible without 3D printing, which allows you to quickly develop new fixtures and grippers and test them then in real applications. So we also need to, of course, the whole work cell needs to be reconfigurable to prepare the workspace. And here we also looked for a bit different solutions, which provides us with more static stability than standard beams that you often find in research labs. So you also need to be flexible with how you bring products into the work cell. So we developed this plug and produce connectors, which allows us to quickly bring new equipment into the work cell and put the objects and tools exactly where we want them. So there's also sometimes the robot needs to move to different positions. So here you have a passive linear unit which allows you to change the workspace. So all this then allows us to, for example, to implement a production process. So if, dealing with the assembly, this is just one of the 5 examples we are dealing with Reconcel. And basically, we are using robots here to assemble these light housings that you can see here. And basically, the company, up to now, the company has special assembly devices for each of these light housings, and they need to keep these special assembly devices for many years because they need to produce spare parts. But if they can use robots, then they can avoid all this. So this is a very good solution for them. And of course, our new hardware was very important to actually implement this task using programming by demonstration. So everything here was programmed by demonstration. And so by now we already did the successful so-called PPAP test. And I've never heard of this before I started to work with companies, but it is production part approval process, which you need to do before the company can actually put this into their production. So just to conclude, so what did I learn from this project? So new innovations are basically necessary if you want to bring new technologies to market. And so you need to work directly with the end users to actually accelerate this and study their use cases and provide and propose new innovations. And then you can, so the innovations do not necessarily just relate to your technologies, but once you have these new technologies, of course, you can then think of also new production processes. So like in this case of assembling automotive lights, which will be now done completely differently than before. And as Tamim and Marcos were already discussing, so new innovation can also kickstart new research directions. And so in our case, we would actually like to go further by developing better approaches for optimal gripper design, optimal fixture design, and optimal work cell design. So this basically, this does not make much sense unless you have all these reconfiguration technologies. But once you have it, you can start actually doing reasonable research in this area. And for that, they then again need more of the FP7 style projects as well. So thank you for your attention.
So to kickstart the discussion, yeah, there are a number of points, but first I want to highlight that I also see that innovation is essential for research, but research is definitely essential for innovation. So we must continue investing in research. You know, I mean, the people who know me know how much I'm also supportive of research. So we have to continue our excellence research, and this is a key point. Now, one of the questions I'd like to address to the audience is how to reconcile the research and the innovation. So we want to use the people where they are the best at. So we don't want or best professor to spend their time in trying to become an innovator. So we need to use the right skills where they are. So how can we get them the help from the innovation, the business people, the users as well? So this would be my first question. And then the other question is, we have also, and we've seen that in many of these projects, reusing a result of projects. So it's very good to see that there is a continuity. And, but we cannot claim that it is happening in every single project. So we would like to know, I would be very curious to know, what can we do so that we don't always reinvent the wheel? We can build a kind of, I don't know, would it be a solution to have a kind of library or database where people can reuse results of project and continuing building on that, so that it's a growing capacity rather than restarting again? Because what we see a lot of the time in research project, at the end of the project, people go in other places and the know-how is sometimes lost. So these are two things I think it's important for both the research and the innovation, and maximizing the impact of our funding. Is there a microphone?
Thank you. Okay. So I think we need to educate academics, or the remaining academics who have not realized that practical, real, industrial, societal problems can still be researched, right? So in FP7, we published a lot of papers with clever mathematics about vision-guided grasping, and we demonstrated picking up plastic teacups, right? What I did is I persuaded all those professors who are much smarter than me that instead of picking up the plastic teacups off the lab bench, they can do just as clever, advanced machine learning mathematics, grasping, but picking up this nasty nuclear waste for societal problem. And you know, grasping rubber gloves and deformable objects from a cluttered heap is a much more profound vision problem and grasping problem than what we were doing in FP7. And then actually what we realize is actually trying to solve the real problems is academically and intellectually more challenging than what we were doing as theory before. So I don't see there needs to be such a separation. Mm-hmm. It's more opening the eyes of the academics that they can do just as clever research, but motivate it with a real problem. Yeah.
Thank you.
Possibly I will say something in the same line. Okay, just I tried to present the evolution. So 2011, we got an idea to transform these aerial robots, instead of only making photographs and taking data, to be able to manipulate. At that time, this was the very first project on aerial assembly, right, with aerial manipulator. The result of the project were many papers, I have to say, many papers. I don't know, but possibly near 100 papers or 80. And this was, in my opinion, very good. But also we have on board the companies. And this is, in my opinion, the important aspects, to have together the researchers from the academia and also the companies. And then, from all these results and all these ideas, in the Horizon 2020, we got aeroarms. In aeroarms, now the problem was to implement for inspection and maintenance. Again, with many companies in the consortium, and again looking to concrete applications. So, in my opinion, the good things are to put together research, not only in the, for example, FET or ERC that is more oriented only to research, but put together with the companies, researching with the company, and for me, one of the key aspects is research and innovation together. So this is the first. And the second is, if successful, maintain the support in application or in other aspects. This is, in my opinion, something that will give, for sure, results.
Tamim, you had a point as well?
Because much of the work which has been done in grasping in FP7 is actually the basis for what can be done now in Horizon 2020. Actually, the European projects on grasping in FP7 like GRASP, DexSmart, Handle, and all of them, I can count all of them, because I was involved in GRASP like Marcos. Actually, they were the first attempts to talk about grasping as non-control problem in the scientific community. And I think in aerial manipulation, I mean, there are so many scientific challenges like contact-based maintenance and so on, which are from scientific point of view would never be possible without these 100 papers what you produce in FP7. But I see a little bit, and I think this is also what Marcos' message was, that it's too much emphasis on the success of projects in Horizon 2020 is very much measured in terms of transfer and see how approaches are feasible and applicable in industrial applications. But this cannot be only the one thing, actually.
I appreciate the huge amount of research that was done to develop, all this advanced vision-guided grasping in FP7. And all I'm saying is that we can continue doing that research and developing it and be academics and make papers, but let's demonstrate our grasping methods on some objects and data sets that are industrially relevant. That's all I'm saying. And when you try to do it on those industrial objects, you will probably find that it's actually a little bit harder than what you were doing before in many cases, right? And that actually becomes academically interesting. So, let's, instead of the vision benchmark data sets that's all tables and chairs and whatever, let's do vision data sets of automotive parts in a heap in a bin, right? Yeah, I think so.
So you want to drive scientific research from grounded in real problems.
And it's not difficult to do. It's not difficult to do. Just go down to the local car factory and ask them what their parts look like, and set them up in the lab. You'll find you get all sorts of reflection of the metal messes up the cameras, the arm coverage, and the bin, you've got some interesting problems,
But sometimes it's confidential issues which you cannot actually build a database of parts of Audi or BMW car.
Absolutely. I had this problem, right? Because we were looking at Jaguar Land Rover, and they had this bin full of these funny shaped metal parts. And they didn't want us to publish papers, right? So I said, go buy some washing machine parts. Doesn't matter, as long as some funny folded shaped bit of metal, it's in the right ballpark, right? It still looks industrially relevant. It's not that difficult to do.
Yeah, so I wanted to say that I agree actually with this, that you need to consider this industrially relevant problems, and in this respect the Horizon 2020 I guess is a success because it really made people speak more with the industrial people. So this is, I think, a positive thing. And but it's not easy I mean, I think it's actually quite exhausting often because you need to, normally there are okay, so maybe there are cases, when it's clear what is really relevant, but often there are many iterations between you and industry people before you actually now figure out what he means and what is really relevant, because what they think is relevant, it's not always relevant also. So, I mean, this collaboration is important, and in this respect, I guess the Horizon 2020 is good.
Yeah. That I can understand. But it's also important to demonstrate and illustrate the impact of your result in real application, so that we can justify to further invest in research, to continue, to have other application and continue the impact. Because if we only show result in paper, they will say, okay, and then now how are you, or is our economy benefiting from that, or citizen benefiting from that? And sometimes you see some of our very nice results not exploited in Europe, and we want to have them also used in Europe. So we should continue the research for sure, but we should find solution as well to use them and exploit them in new products, in new processes as well. And you had very nice test cases with real application and demonstrating the added value of all your research. So that's very good to show.
I think in that respect it is also very important that the projects that we are talking about here always have end users, and meaning end users, not maybe the final customers, but especially also those companies who will produce the innovations that will come out of the projects. And on the other hand, but that's more when we are talking with national funding than with European funding. Especially in Germany, we always have to find a balance, because if we stress the interest of a company too much, then we may lose the grant, because then they say, okay, if the company is so interested, they should give the money. And I don't know how much that plays a role in European funding, but I think that is sort of your problem if you're proposing to the Commission typical means of funding. Possibly there are also some people who say, okay, there are some typical companies who have money on their own. So maybe, but maybe people from KUKA, Siemens, other companies may kill me for that, is that there should be some sort of funding where in the consortium there should be large industrial companies, but they will not get funded. The question is how you make them participate really in the project once the project is being approved. But maybe that is also something that we have to think of.
But tell me, why does or do these things work better in the US? All these things. I mean, there are big players in the US, yeah, and there are crazy researchers.
I think
I think they are at least as successful as Europeans regarding innovation, if not more successful, yeah.
I really
so there is a completely different concept there, right? I mean, if a big industry realize that Michael Supa or Sami Haddadin has cutting-edge technology now, they give him a huge amount of money to solve a specific problem for them. Why does this not happen in Europe?
I think I could imagine there are two reasons. One reason is that if we look at us researchers, I think we have not been so agile as probably researchers in the US. Not so much agile in finding our research topics, but really bringing our innovation into the market and being willing to start spin-offs. I think that changes a little bit. And since that has been so in the past, it is still, so to say, in the mind of people who are giving financial means of private companies, equity companies, so on, who are giving money. They still have the feeling that if they give the money to US researchers, payback comes faster than from European researchers. I think it's still an idea they have.
Why? Why are we accepting these ideas?
Maybe we do not market us as good as we do. I know there are also events organized by the European Union to bring together venture capital companies with researchers, but maybe we still have to increase activities into that area, because that's what I could imagine would be helpful.
Yeah, maybe in the US also the model, it's better acknowledged that and this is a duty of the professor, they have to look for money for part of their salary even, and to build up their teams. So this is a model which is embedded in their life, in the life of a professor, which is less, something which is less developed here. Yeah, but maybe we can do, like you propose, some activity.
But I mean, this was just my thoughts. I'm not really an expert in it.
So Michael, you and Sami, you wanted to say something? You wanted to say something? You raised the hand. Yeah.
I can come up to you as well. Okay, maybe two remarks to that. I think that it's a complete different concept, right? In Europe, academia is somehow, like from the academic side, tighter, closer coupled to industry already. So in the US, you have academia as an academia thing, and then you have paid money from industry for research, and these guys then get also an additional funding and so on. So these people take much more risk by just giving money to see what's coming out. And I'm not sure if everybody, like especially for me, like writing 100 pages for a proposal that has an acceptance rate of 10%, I don't, right? Because I don't have the time for it. So in that case, it is also something that the funding scheme is different. It's not public money, right? It's mostly private money that is financing the innovation there. Because people are taking risks and they know that 1 out of 10 will not make it. Or 9 out of 10. So 1 will make it, and yet they will lose a lot of money. So that is a completely different scheme. And the question here is, what can the public sector do to push that innovation in that direction, but at a level that it is, in terms of like effort, bureaucracy, okay for also companies that don't have large departments doing this. And on the other side, also being willing to take a risk. So you don't want to have the result in the beginning, right? You must look into it, and it may also fail. And if it fails, it may also something that you learned. Yeah. And this is really the difference. So if you can fail, then you just go faster and you do more. Because if you always have to deliver, that's a different thing. And that's what I would say in that perspective.
Sami.
Yeah, this is your comment.
So I think this is a major point, that we don't have industries which are willing to take a very little of risk, you know, in financing or pushing anything. They want to see 100 euros in advance before investing 1. In the US, it's different. They invest million before getting 1. Yeah? But this is, I think, not our problem as researchers. This is a problem of maybe industry, and maybe also how to structure the new program, actually, because even they get paid for it in Horizon 2020 now, industry. Yeah.
Mm-hmm. Yeah, so I mean, I can only support what the others have said so far, actually. I mean, I think one of the main problems that we have at the moment still, but it gets a bit better, I think, at least I have the feeling, is the circumstances for young high-tech startups to get on their feet quickly. So getting the first round is very easy. That's a no-brainer. Everybody can do it nowadays. But the question is when I mean, Marcus was also pointing out, if you build hardware, it takes forever. So collaborative robotics, collaboration for the sense of collaboration, let's not talk about that. I think it's about manufacturing, right? The system should do something. They should actually do assembly. So let's go for the value creating problem there. But creating something like this takes a lot of time, lots of money. And so there's this kind of gap in the sense of the financing of young companies. So creating a first, I don't know, test case is very easy, and then you need a bit more money. You need the first million is maybe okay, but when it comes to the 3-4 million, then it gets really hairy, I think. That's kind of where I believe you have to be really cutting edge in Europe to actually get to that case. So that's one thing. So we need to create much better environments for the young startups to get finances, which has lots of reasons. The other thing is that our universities, I guess, and also the research organizations so far are not designed for creating, in terms of a pipeline, these 10 high-tech startups so that the financing people can actually play that game. So if you just create as research 2 or 3 of these companies, but you want to make it a game in terms of you have to invest into 10 in order to make one successful, you basically don't take the risk. So you cannot take the risk anymore. So the game is not working, right? So you need to create a certain amount of companies in order to be able to play that game, this 9 out of 10 game, right? And maybe another thing is also the company thing. So we actually see lots of tremendous, I mean, there was many acquisitions in Europe, right? So it's not that the technology and the young startups are not there, but they don't, because they don't have the funding for the 3, 4, 5 million, they actually get acquired much sooner than maybe they should be acquired. So we saw this over the last couple of years a lot. So we had tremendous success in basic research, in first technology, in spin-offs, and then after 1, 2, maybe 3 years of extreme success and wonderful showcases, it was actually not the European industry, so they couldn't grow. That's one thing. But so they had to be taken over. They had to get the exit, and then they were acquired by US or Far East companies. Japan also is very active at the moment. So this is, I think, one of the large-scale issues I see there. And yeah, and obviously I also want to support very strongly that we need to have basic research all the time. So it's not, if Europe cannot manage to do basic research continuously, then we're really, we're lost, I would say.
It's a good conclusion.
Yeah,
yes, there was one thing.
One comment because I thought that this workshop with innovation yesterday morning, few people there, but was really excellent, where the Odense people presented their model, and present was the responsible person at the town. They're doing that for 20 plus 30 years. I mean, you know, the town is funding an office to bring companies and investors together, and they came, the responsible person came, plus an investor, plus a person that moved from Sweden to Denmark because the situation is so good. And I know from my Austrian colleagues, you know, it's just amazing. I mean, I keep telling the university in Vienna, look at this model. It's not even robotics. It's like every other thing. They are doing it right. I think using and making more public these really good success stories might be a way. And then I still need to talk every day to my government or you know, ministries, university on town, starting something in a big city like Vienna. That would be even, I mean, we looked at what we have in Vienna, it's just horrible in comparison. But that might be.
Well, my comment is related to USA versus European Union. I know more or less, well, I know something from the USA. I was also working there, but I have many colleagues. So bureaucracy, as mentioned, is a big problem for us. Every day in all the groups, we have to pay more and more to have accounting systems and to have cost justification. And we are always pending that somebody will come 3 years later of the project or 4 years after the project to subtract the money. And then because that, our organization put more barriers to be sure that never, so pay and pay and pay more. When in the USA, it's just a grant and produce with these grants and results. Why we have to spend so big money in accounting systems, in audits, in everything, internal audits, I mean, and everything just to be sure, just always to be sure. This is one thing. This is a bad thing for us. In my opinion, this cost is increasing a lot in our organization, But the good things that we have to maintain. So, for example, in USA, it is quite difficult that competitors participate in the same projects, both for companies and for university. For companies especially, we can have in European projects competitors in the same project because they want to have the same technologies on services, and they put the specification. They are working together to define the specifications to validate the system. This is unique. Americans do not have this. And also, with our colleagues, we collaborate to have joint initiatives inside the projects, and this is very good. This is also not clear in America because they compete. Okay, we have the competition, first phase, second phase, third phase. So we have to compete. We know how to compete. But at the same time, we have to maintain this collaboration, promote collaboration in Europe, in my opinion, is basic, fundamental of our system, and we should maintain.
I think it's an excellent conclusion.
Yeah.
Did you want to add anything?
No, not at this point.
So thank you, everybody. I think we had a very nice example. Yeah. We need to show those, to make it known outside of the room as well. And very interesting discussion. We should continue it as well. And thank you, Tamim, for the work of organizing, and my colleague as well. And I give you the last word.
Thank you, actually, for helping here. I hope, we wish Anne, of course, a very fast and complete recovery. I think we had very interesting discussions, and I hope that next year we'll have at least 3 finalists in the innovation radars, and maybe the winner is also from robotics, so that we can continue actually or organize a similar workshop at ERF 19. So thank you very much. Thanks, Cecile, and thanks to everybody.
Thank you.